Hi, everybody. All right, I accidentally clicked the box and I can't unclick it. I know you won't, but you'll see it tonight. So, okay. So sorry you have to see my ugly face if you were absent today, and um, I accidentally clicked the box and I can't get rid of my picture. So, all right, so here we go. This is weird. I remember back in the day when I taught Algebra 2. Boy, do I miss that class. By the way, have I mentioned that? All right, Algebra 2, back when math made sense to me. I would teach imaginary numbers, all the operations that we just went over as bell work. Okay, and then at the end in the Algebra 2 book, with no explanation, they would say, this is how you graph an imaginary number. Like, why would I care about doing that? Oh, well, it's in the book. I'll teach the students this. And then I ended up teaching CAT, and then I understood why, because it opens up a world of math for you a little bit. Now, again, we're just going to extend it a little bit further with doing sections 8.2, 8.3, and 8.4. But then you have to understand that it opens up your world of fumble, imaginary numbers, and applications for them. So here's the start of it. And all this is overwritten, but it's all great. Like I said, this book is awesome for you if you are missing to be a college student. Oh, we did A2 today? Let me open up the book and read it and read the examples. Oh, I get it. And then move on. That's why I cut the book, because the book is great. So I have the standard A plus BI number. And what you can do is create a coordinate plane called the complex coordinate plane, where the x-axis is called the real axis, which incorporates the real part of the imaginary number. The y-axis is the imaginary axis. So what I could do with 2 minus 3i is treat it as 2 negative 3. Treat it as a coordinate that I can graph in this complex coordinate plane. And then what ends up happening is, now that we do that, we can treat this like we treat vectors, right? Doesn't this look like a vector that we just had in the last chapter, right? Where the vector was named by its endpoints, where it lands. And then for this vector, we could actually now find the what of it. What's that called of the vector? Magnitude. And then going this way, of course, I could find its what? Direction angle. And we can put that in degrees. So that's exactly how this is going to look exactly like what we did in vectors. But now what we're doing is being able to do math later in later sections with these imaginary numbers. And we can do it, we can do all of this section that we just did here, like some of these multiplying and, you okay? Okay, all right. Thought a student was dying there. Just going to make sure. Through trig instead of, conjugates and all this other stuff. Maybe not powers of I numbers, but, well, yeah, actually, yeah. That's exactly what we can do. So, just accept that. Then we can understand this. Well, this is easy. And I don't think there's any problems like this in the book that I ask you to do this again. You did this in 8.1. But just imagine you had 4 plus I and 1 plus 3i. And imagine you had to add these together. Well, of course, all I do is take 4 plus 1, and I'd take 1i plus 3i. And that would be the answer rectangularly. But now we can incorporate this with vectors. And how do vectors add? Well, if I graph 4 plus 1i, 4 right, 1 up, that's 4 plus 1i graphed in a complex coordinate plane. And then this is 1 comma 3, 1 plus 3i graphed. The addition of these vectors is you take this vector and you just tack it on to the end of the other vector. That's how you add one vector to another. And the answer to the sum is called the resultant of those two vectors, which in turn is 5 plus 4i, which is what you got when you actually added them just by how you know. So again, just to open up your world, that you can create this weird coordinate plane called a complex coordinate plane. By the way, I would verbalize this with the other hour. I'm going to zoom in on this like white space right here. Remember subsets of numbers? Natural numbers were counting numbers. Anyone ever see this before? Whole numbers. What's after whole numbers? Integers, which for some reason most books use the letter Z for that. Just listen to what I say. What's after integers? Irrational. For some reason they use the letter Q in this book. I have no idea. I'm being honest though. This is what they do. All right. And then what's all the way up to irrationals called? Let's keep it what, man, if we want to be cool? Real. But then we have this whole subset of numbers over here called what numbers? Imaginary. And then there's this whole incorporates all these numbers. That's actually complex. Complex is just a term that means both real and imaginary subsets combined together. And that's the world that you know. That's all the numbers that you know in your life. Okay, so understand when I say the term complex coordinate plane, that incorporates both real and imaginary. Okay, I said that last hour, but I wanted to verbalize it. I'm going to actually write down that chart of numbers again that we've seen so many times. And then this is why this should not be hard. And I yelled at you. You yell at us every day, Mr. Samuelus. I yelled at you that do not make this complicated. If you actually draw these things, then you have a triangle, and then you can basically not even use Sir-Kix or Tix. You can use SOHCAHTOA to figure out what do I need in order to solve for these missing parts. So they turn around and use X and Y, in the book for X plus YI. I firmly keep saying A plus BI. Do you remember that from years ago? Right? Do you remember that? But just remember that A is the horizontal move, B is the vertical move. All right, so then I'm going to change these formulas accordingly. I did this with the other hour as well, because I'm always going to use A plus BI as the standard format of an imaginary number. So now, a couple things here. So what's the relationships that I know, and then how do I get this trigonometric form of these numbers? Well, look at this. I'm given, hold off, let me get my mind right for a second. Oh, these formulas are, if you're given, I probably should have reversed this, R and theta. This is how you can find X and Y, and actually this is all the relationships, I guess, all together. Say you had to find A. So this puts them all together, how you're going to have to find this stuff. If I'm going to have to find A, I would have to have theta and R. Okay, so what is A in relation to theta? What side is it? What side is it? Adjacent. And what side is this? Hypotenuse. What deals with adjacent and hypotenuse again? Cosine. So really what this is cosine of theta equals A over R according to this drawing, and then multiply both sides by R. And then say I needed to find B, which I have to change this to B for my A plus BI. I want to keep it that way. If I had to find B, what side is B compared to this? Opposite. And then what's this? Hypotenuse. What deals with opposite and hypotenuse? So you take sine of the direction angle, and that would equal B over R. And then you multiply both sides by R. So this is how you find the A plus BI if you're given the theta and the what's called the magnitude. Sorry, words are struggling on a Monday morning. Then, what if I'm given these two values and I wanted to find R and theta? Well, what can I simply do to find R, which is just this length? Pythagorean theorem. Instead of X and Y, I just change them to A and B. And then, what side is this? What side is this? What side is this? What deals with opposite and adjacent? Tan. So instead of y over x, it's b over a if you want to change it in our format. So this just shows you exactly what we did in vectors, but this is now in a different world, a complex coordinate plane where we graph an a plus bi number like it's a coordinate. Okay? All right, so here it puts it all together, and then there's some weird notation for this. Now we're going to do some substitutions, which is simple. And again, I'm going to use a and b. A plus BI can now be written like this. R, wrong, yes, that's right, cosine theta plus, let's make it R sine, yeah, let's do it like that. So all I did is change the x and y to be a and b. And all it is a simple substitution. Looking up here, a equals r cosine theta. So I take a out and I put r cosine theta in its place. B equals r sine theta. So I take b out and I put r sine theta in its place. That's all that happened. So this is a way to express an a plus bi number, knowing that we can graph it in a complex coordinate plane in trig format. Fumble. Big one. Now, notice this. This is mathematician laziness. So what we could do is if we notice that there's an r in common, we could pull that r out, and then what mathematicians do is rewrite this in this format. And I'm going to do that for every single question. All you have to do is be able to read it. So if I go back to this one, maybe I could put it cleanly here. They did factor out this r. And then what this can be rewritten as, because mathematicians are lazy, cis theta. And all cis theta means is exactly that. Cosine theta plus I sine theta. And it's just a way of shorthanding your notation. Okay? So these are called cis numbers when we do this stuff that we're doing. So I have a student. I told them to think about their 60s, 45s, 30s, and 90s and all that to be able to actually do this. So the way this could be written in the book as a question is, this is for cis 60. I know that was brand new to you, and that may cause, what? And all you got to be able to understand is cis 60 means this. 4 times the cosine of 60 plus I sine of 60. All right? And then notice what it says. Write each complex number in rectangular form. Rectangular form is a plus bi form, the only form you've known up till today. Got it? But this is how easy it is. Oh, you're on the spot. I remember asking this before, and you weren't quite the pro at this. Hopefully you got cleaned up on this. What's the cosine of 60? Shh, silence. Then we'll go offline for a second. Okay, so I just yelled at him. All right, but if you don't know them right off the bat, super fast, draw your triangle. Now, what's the cosine of 60? Kixer. Huh? What's the sine of 60? I guess I'll do double parentheses here. Sir. And then all you have to do is do this. And now you got this in a plus bi format. What's the final answer? 4 times a half is, half of 4 is, plus, and then the last hour student didn't know what to do with this. What do you end up getting? Of course, we talked about second hour. And that one student said, what are we doing? The other student said, I have no idea, after 30 minutes of notes. Okay, 2 goes into 4 2 times, so just 2 or 3, and then maybe write the I out in the end. And then understand, everyone in this class, this is the format that you already know. That's the format that you've seen I numbers in since you've been taught them. Okay? So basically the first example is just taking a trig version and turning it into one that you know. And that's it. Uh-oh. Oh, no, that's not an uh-oh. Here we go. What's cis mean? I have to find the... You know your student 9, right? So what's cis mean? What's the C mean? I have to do what with this 315? Cosine of 315. And then what's the IS stand for? What do I write next? But it's plus, right? I sine 315. Here we go. This is why I get... What's the cosine of 315? I asked this last hour to see if they just get the answer without me explaining it. Loud and proud. So the first one is root 2 over 2 plus, what's the sine of 315? Sir. Okay, and then now we have this radical stuff. So I've evaluated the trig. Now it's going to be an a plus bi number that I recognize. How do I multiply this? I've been the fraction jerk all year long. I hope we know how to do this. This is root 3 over 1. So what does this become when I take root 3 over 1 times root 2 over 2? Plus negative root 6 or minus. You got it. A plus BI. All right? Recognize this angle measure as like an exact? No. What does that mean then? If this isn't exact, what does that mean I might have to do? Use your... What? Boo! It's scary. What number is that? 1. So all it is find the cosine of 110.5. Find the sine of 110.5. Go ahead and do that, and then we'll turn on the video after that. Calculator, type them. Make sure you're in degrees. A plus BI. That is the format of that number now. Taken from trig format. Okay, and then this is the reverse, which actually I should be able to just, I re-put the notes here, what we're here. But when we do the reverse of this, those were the formulas for that, and I should be able to, prove that by simply graphing. It drives me nuts how many students say, I don't know what I'm doing, when most of this comes back to drawing a triangle. And that's all you have to do, then you can figure it out through basic SOHCAHTOA. And there are many times that can happen. Make sure that you have the correct angles quadrants, specifically to these directions before I get a student. Okay, the directions are specific. Sorry, bad computer usage there. Where write each complex number in trigonometric form, r cis theta form, where theta is between 0 and 360. That's the rules. So that's what you have to do when you actually do this. And this is why this is 100% review for the next student I'm going to call on. You're done, right? I didn't say your name. What it comes down to is if you're stuck, you make a what? Triangle drawing. So that's exactly what we do. This is the very beginning of the notes. What do I do with 1 plus I root 3? What's my movements? Remember, A plus BI. I always write it that way. All we're going to do is graph it as A comma B. So what do I do for 1? Move 1 which direction? No, it's the x-coordinate. 1 which direction? Right. Move it and draw it. And then what do I go for root 3? Up. What I'm trying to find is R. They use that term, that letter R. Don't worry about the letters. I think that word R means radius again. And then theta. We're trying to find that direction angle. How many people know the answer? Know what R is and know what theta is? Everyone should have their hand up right now. Ah! Okay. I'm literally going to run down the hall screaming, and I'm going to leave it all in the video of me running with my face if I don't get what. Everybody, what's R?
2.
What the?
2. It's 2.
R is 2. And then what's this angle measure opposite root 3? It's over. And if you don't know that, that's why I want to scream and run down the hallway, because how many times have you seen these triangles drawn? How many? Too many to not know what these are. Yes, I'm gritting my teeth. Now you get to see it. Okay? There is no excuse for you not knowing these triangles at this point. So, Nick, what's the final answer? Remember, I said his name! George, Frank, Henry, just random names. Or, Sally. Could have been a guy. Who knows who's up right now. Okay, how do I write this final answer now? So what do I do? Nope. You're writing this in this format. Filling in the parts. You basically have the parts. So go ahead. 2. Good. Now, oh, that was so hard to write all that out. I'm a lazy mathematician, so I'm going to write this. 2, anyone? Cis 60. And that's the only purpose of this, so I don't have to write the angle twice and write all that. You as a mathematician, this is what you got to figure out today, that's what that notation means. And you can write all your answers like that. Yes, you could. This is supposed to be an A plus BI format. Interesting, and this is all that I have. So what's A? I, you, what's A? 0. And then how do you save yourself? You do what? Draw it. How do you how do you graph? How do you draw 0 minus 2i? What do you do? Would you be quiet, please? You're not up. There's rules in this classroom. I pick on my students. I know which ones I want to have answered. Okay? So how do I do this? What do I do? Okay, so again, we're not getting far here. I just have to graph this as A comma B. So what's A? And then what's B? So what kind of 2? So how do I graph 0 comma negative 2? I go what? Not up. What are you saying? Down. Okay, now, just to speed this up. Do I hear something? I think the Angels are... Whew, something just happened there. I'm just glad to be alive. I am happy to be alive right now. Here, I'm just going to finish this one off. Class, everybody, what's this angle measure? What's that angle measure? 270. What's this distance, which is out? That's all. The word that starts with M again. Magnitude. A little flustered right now. Okay. The length. What's that length? Tell me the answer. Now it's two. It's 2. Why? Why? What's length? What's R always? Remember this from back in the day? Sir kicks or ticks. It's always positive. The angle measure will get the negatives where they need to be. 2 what? Sis. Sis who? Sis who? What? 270. And then I'm done with this. Okay, no more students. We gotta get this moving. So a save out of this. Again, I have to make this this A plus BI number into some sort of R sis number. So I have to find R and theta. Okay, that's what I have to do. If I don't know what to do, I graph it. Where's negative 4 comma 1 end up at? 1, 2, 3, 4. So negative 4 comma 1. And then how do I find R? What do I simply do, everybody? Pythagorean theorem. Oh, that's why this formula is written. This is just a Pythagorean theorem, which is root what? 17. Ooh. And then how do I find this theta? Oh, is this a triangle I recognize, by the way? 1, 4, root 17? Heck no. So what do I have to use? Calculator. So, hey, now that I found that, I could actually even use this. I could use root 17, and I could do, inverse sine. You have options, but we're just going off what's given. Opposite and adjacent is what for theta? Tangents. Now we'll ask offline that you calculate this for me, because something's wrong that you got to fix. Why can't that be the answer for this? It's supposed to be between 0 and 360. So what do I have to do for this negative 14 degrees? Well, it's actually 14 degrees right here. What do you simply do? 180 minus that reference angle. And what is that? Someone say it out loud so we can end this. 165.96.